Today we talk about the remainder theorem. For any polynomial p of x, alright, its remainder can, when divided by a linear function x minus alpha, is just going to be p of alpha. This is very simple. And this is the implication of this particular theorem, is that if your divisor, this is called the divisor, divisor, if the divisor is x minus alpha linear function, is a factor of p of x, then obviously if it's a factor of p of x, then there is no remainder. If there is no remainder, then p of alpha must be 0. So this is an if and only if statement, that is both way, right? So now we look at some more. P of x is called, usually a polynomial p of x can be written as a summation of a divisor multiplied by a quotient plus a remainder, right? And the degree of the divisor must be larger than the degree of the remainder. The degree of remainder must be at least equal to 0. That is, it can be a constant number. And for linear, if the divisor is linear, this is what we have. So we could have a function like this, right? X squared plus, for example, 9. And I want to figure out, well, what is the divisor? Well, the divisor could be x plus 3, for example. That's the divisor. Well, one way to do this is to do long division. This is what we've done in long division. So in order to figure out this, we can say, well, x, right? X times x give me x squared. X times 3 give me 3x, right? So here you can see that 9 here cannot minus 3x. In fact, there will be here 0x plus 9, for example. This. So for this particular method, you have to minus the top one by the line below. X squared minus x squared is 0. 0 minus 3x is minus 3x, so minus 3x plus 9. This one comes down. So next, we have to think about, alright, what number do I need to put into here so that I multiply together and get negative 3x? So the answer is negative 3. So negative 3 times x is negative 3x. Negative 3 times plus 3 is negative 9. So again, you were going to be minus off, the top minus bottom. So here gets 0. Here we get a 9 plus 9 is 18. So in this particular case, there's a remainder 18. Another word is that if I write this out, x squared plus 9, I have to write it as the divisor here is x plus 3, and the quotient is the one on top. The green thing on top is the quotient. X minus 3, and then my remainder is this one, plus 18. That's my remainder. Just apply the remainder theorem. So in this case, it's just put in 1, because, why is it 1? Because x minus 1 equal to 0, x is equal to 1. So we put enter 1 into here. Then it's 3 times 1 squared minus 2 times 1 plus 1. So here is the remainder, in this case, is just 2. There are many ways to do this. Well, one way to do this is to use long division like used before. So for example, 3x squared minus 2x minus 1, I use long division. Right? I'm going to do this very, very quickly. So 3 times x gives you 3x squared minus 3x. And then here I'm going to have the top line minus the bottom line. So that gives me 0. And negative 2x plus 3x gives me an x. This now comes down, x plus 1. So in order to get x here, I need to have plus 1. So giving x minus 1. And again, top line minus the bottom line, then I have a remainder of 2. And you can see that this 2 matches with the 2 above, which you expect to. So basically then I can rewrite this as P of x here can be written as x minus 1 times 3x plus 1 plus 2.